All right, we are now on 614, which is factoring trinomials, so 3 things, and this is just day 1 of it. We're going to spend 2 days on this. Okay, again, we're going to warm up first, so we're going to practice our double distribution skills. Okay, if I do x times x, that gives me x squared, and x times 5 gives me 5x. Moving to 1. 1 times x gives me 1x, and 1 times 5 gives me 5. I can combine my 2 middle terms, so I have x squared plus 6x plus 5. Okay, for the second one, m times m gives me m squared, and m times 6 gives me 6m. Negative 4 times m gives me negative 4m, and negative 4 times 6 gives me negative 24. I can combine my 2 middle terms. I keep the m squared, and 6 and negative 4 make a positive 2m, and then I bring down minus 24. Okay, so k minus 7 times k minus 3, k times k is k squared, and k times negative 3 is negative 3k. Negative 7 times k is negative 7k, and negative 7 times 3 is positive 21. My k's will combine, so I keep the k squared. A negative 3 and a negative 7 make a negative 10, keep k, and then plus 21. Now, these trinomials can be factored back into these binomials. We're going to go from this to this today. Okay, so to factor a trinomial in the form of x squared plus bx plus c, so just like these, you must find 2 integers that add to b, the middle term, and multiply to a times c. All right, so a guide and an example. What 2 integers have a product of 12 and a sum of 7? Because we're doing 1 times 12, and then that middle term is 7. So if I look at my factors for 12, like multiplying to 12, I can do 1 times 12, I can do 2 times 6, I can do 3 times 4, and then there's no more multiples of 12. So now I want the ones that add to 7, which would be 3 and 4. Okay, so you're going to write 2 binomials using these integers and then distribute to check. So since I use those integers, I just take my letters, x plus 3, and I do x plus 4, because those were the 2 numbers I got. And now we're going to check it. X times x is x squared. X times 4 is 4x. 3 times x is 3x. And 3 times 4 is 12. When I combine these, I get x squared plus 7x plus 12, which is back to my original problem. All right, now the way we're going to do this is I like to use a big X for the method. Okay, so over here in the corner, I'm going to put an X, the size of about that size. You don't want to take the whole box. Okay, you're going to do A times C, so 1 times 18, and write that number right here, which is 18. Your sum, your middle number, always goes right in the middle, so 9. Now I'm going to come over here, and I'm going to list the multiples of 18. I've got 1 and 18, 2 and 9, 3 and 6, and that's it. Now, if you don't know your multiples of 18, here's this really cool trick. If you go to y equals, and you type in 18, and you divide it by x. If you go to the table, it will list them for you. 1 and 18, 2 and 9, 3 and 6. Don't use 4 because it has a decimal. Don't use 5 because it has a decimal. And then if you notice 6 and 3, we've already written that. It's just they flip the order. So those are the only numbers, and now I need the one that adds to 9. Well, 1 and 18 cannot add to 9. 2 and 9 will never be able to add to 9. 3 and 6 can add to 9. So I put 3 here and 6 here. And if you notice, I kind of put them up a little bit higher, because the next step after you do that is to always divide by that first coefficient, which is a 1. So 3 divided by 1 is 3, and 6 divided by 1 is 6. So to write your answers, since you have whole number answers, you're going to do x plus 3 because this became a whole number, and you're going to do x plus 6 because that became a whole number. If I double distribute this, I am back to my original problem. Now, I did make a mistake. This should be a W, but I don't care what letter you use as long as you have these numbers right. Okay, for number 4, I've got y squared plus 2y plus 1. I'm going to take 1 and multiply it by 1, which is 1, and I need to add to 2. So my multiples of 1 are 1 times 1, and that's it. That also adds to 2. So I put a 1 here and a 1 here. I'm going to divide by 1. 1 divided by 1 is 1. 1 divided by 1 is 1. So I'm going to put y plus 1 and y plus 1. Or since these are the exact same thing, unlike the other problem, you could write y plus 1 squared, and either one would be fine. Okay, now set 2, we're going to change it a little bit, because if you notice, all of set 1 have a plus plus sign. This is going to go to a plus minus. So I'm going to draw my x. 1 times negative 8 is negative 8, and I bring down the 2, so I'm going to do multiples of 8. 1 times 8, 2 times 4. There's no more multiples of 8. So I need the one, now since you have different signs, you have to now ask that could add or subtract to 2. So if I have 1 and 2, if I add those, I get 9. If I subtract them, I get 7. So this one will not work. If I add these, I get 6, but if I subtract them, I get 2. So this will work if I make that a negative 2. So 4 minus 2. So I'm going to put over here negative 2 and positive 4. I'm going to divide by 1. When I divide by 1, I get 4 over here, and I get negative 2. So since these are whole numbers, it becomes x minus 2 and x plus 4. If you aren't sure, just double distribute and check your answer. For number 8, okay, we're going to do 1 times negative 45, which is negative 45. My b term is 4. So multiples of 45, we got 1 and 45. 2 won't go into it. 3 will. 3 and 15. 4 won't go into it. 5 will. So 5 and 9. 6 won't go into it. 7 won't go into it. 8 won't go into it. And we're back at 9. So now I'm trying to find the one that adds or subtracts to 4. This will give me 46 or 44. So not it, depending on which way you go. This will add to 18, but subtract to 12. Not the number I want. This will add to 14 or subtract to 4. So to get it to subtract to 4, I need this to be your minus. 9 minus 5. Okay, so I'm going to put a negative 5 here and a 9 here. I'm going to divide by that leading coefficient of 1. This gives me negative 5, and this gives me 9. So therefore, I have x minus 5 and x plus 9. Double distribute, you'll get back to your answer. Okay, now we're going to change signs one more time. Actually, 2 more times. There's 4 different sets. Okay, so for number 10, I have x squared minus 7x minus 30. Okay, I'm going to draw my x. 1 times negative 30 is negative 30. And to get to negative 7 for a sum. Okay, so my multiples of 30. 1 and 30. 2 and 15. And remember, you can do this lovely thing in the calculator where you go to y equals and you do 30 divided by x. And it will tell you all of them. So I'll leave that right there so you can check me to make sure I'm not making a mistake. 3 and 10. 4 no. 5 and 6. And that should be it. Okay. Now, if I add 1 and 30, I get to 31. If I subtract, I get to 29. I want negative 7. If I add, I would get to 17, but if I subtract, I get to 11. I want negative 7. If I add, I get to 13, but if I subtract, that gives me a 7, and I just need to make it negative. So this one is possible. If I add, I get to 11, and if I subtract, I get to 1, so no. So now to figure out how to make this a negative 7, you want your bigger number to be negative. So now if you do negative 10 plus 3, that gives you a negative 7. Or if you do 3 minus 10. So I'm going to put 3 here and negative 10 there. We're going to divide by that leading coefficient of 1, which gives me a 3 and gives me a negative 10. So I'm going to put x plus 3 because that was my answer, and x minus 10 because it was a negative. Okay, for number 12, 1 times negative 64 is negative 64, and then I bring down the negative 12. Okay, so again, I'm going to put this over here where you can check to make sure I'm not missing any multiples. So 1 and 64, 2 and 32, 3 doesn't work, 4 and 16, 5 doesn't work, 6 doesn't work, 7 doesn't work, 8 times 8. Okay, so now if I check these, 1 plus 64, not going to get me to 12, and 64 minus 1, not going to get me to 12. 2 plus 32, not 12, and 32 minus 2, not 12. 4 plus 16 is not 12, but 16 minus 4 would give me 12, just not negative 12. And then 8 plus 8 would be 16, and 8 minus 8 would be 0. So in order to figure out how is this going to become a negative 12, if I did 4 minus 16, that gives me a negative. So I put 4 and negative 16. I'm going to divide by 1 and get 4. I'm going to divide by 1 and get negative 16. Okay, so therefore, when I write my factors, I have x plus 4 and I have x minus 16. If I were to double distribute, I would get back to my original answer. Okay, for set 4, again, one more sign change, probably one of the trickier ones. Okay, I'm going to do 1 times 49, which is 49, and my sum has to be negative 14. Okay, so multiples of 49, I'll put it in over here for you to see if you want to see it. You've got 1 and 49, and you have 7 and 7. Those are the only multiples of 49. Okay, now, the only way to multiply to a positive number and add to a negative is a negative times a negative. So I'm going to go ahead and make both of these negatives. Okay, and then if I add them, that will not give me negative 14, but this one will. So I put a negative 7 here and a negative 7 here. I'm going to divide by 1, which gives me negative 7. Divide by 1, which gives me negative 7. So I have x minus 7 and x minus 7, or x minus 7 squared. Either would be okay. For number 16, one more style like these signs. Okay, I'm going to put my x. 1 times 50 is 50, and my sum has to be negative 15. If you want to see the multiples of 50, you should have 1 and 50, 2 and 25, 5 and 10. That should be it. Okay, if I were to add these, that would give me 51 if I subtract 49. If I add these, I get 27, subtract 23. If I add, I would get 15. But the only way to get to a negative 15 is to make both of them negative. So negative 5 and negative 10. I'm going to divide by 1, so that gives me negative 5. I'm going to divide by 1, which gives me negative 10. So this is x minus 5 and x minus 10. Okay, so now for the mixed practice, we're putting all the signs together. Okay, I'm going to put my x. 1 times negative 72 is negative 72, and I want a sum of negative 14. Now, I'm going to struggle a little bit on my 72s. I don't remember them all. So I have 1 and 72, 2 and 32, 3 and 24. I'm going to come over here now. 4 and 18, 6 and 12, 8 and 9. Those are all the multiples. Okay, now I either want to add or subtract to a 14. So this will add to 73, subtract to 71. This will add to 34, but subtract to 30. This will add to 27 and subtract to 21. This will add to 22 and subtract to 14, so possible. This will add to 18 and subtract to 6. This will add to 17 and subtract to 1. Okay, so the only one that works is 4 and 18. And to get it to be a negative sum, I would have to do 4 minus 18. So I put 4, negative 18. I'm going to divide by 1 and get 4. divide by 1 and get negative 18. So therefore, my answers would be x plus 4 and x minus 18. And if you've noticed, I've done x every time, even though when the problem's not x. It's okay. I will accept it. Just be aware that that's not the letter they're using. It's just the one I accidentally always use. Okay, for 20, 1 times 48 is 48, and my sum needs to be negative 16. So factors of 48, you got 1 and 48, 2 and 24, 3 and 16, 4 and 12, ooh, that's about 12, and then 6 and 8. Okay, they either have to add or subtract to negative 16. So this would add to 49, subtract to 47. This would add to 26, subtract to 22. This would add to 19, subtract to 13. This would add to 16 and subtract to 8. This would add to 14 and subtract to 2. So this is the only one that works. But in order to get it to add to a negative 16, since it will add to 16, I need to do a negative plus a negative. So this would be a negative 4 and a negative 12. I'm going to divide by 1, which is negative 4. Divide by 1, which is negative 12. This will become x minus 4 and x minus 12. Or if you want to use the right letter, w. Okay, for the last example before we extend on with GCF, 1 times 42 is 42, and I need to add to 13. So multiples of 42, 1 and 42, 2 and 21, 3 and 14, 6 and 7. Okay, this adds to 43, subtracts to 41. This adds to 23, subtracts to 19. This adds to 17, subtracts to 11. This adds to 13, subtracts to 1. So this one. And I wanted to add it. So 6 plus 7 does give me a positive 13. So I'm going to put a 6 and put a 7. I'm going to divide by 1 and get 6. Divide by 1 and get 7 because the leading coefficient is 1. And that gives me x plus 6, x plus 7. Okay, now when you're doing this, you have to factor GCF out first. So if you struggle with that GCF, remember you can do math over to number 9, do 2 comma 8, which is a 2, and then do math number 9. Take that answer 2 and put it with the last number, I forgot the comma, 24, and I can take a 2 out. They all don't share a letter, so that's all we're going to take out. Okay, when we take it out, I'm going to write the new piece right over here. That gives me x squared minus 4x minus 12, because 2 divided by 2 is 1. 8 divided by 2 is 4, and 24 divided by 2 is 12. Now, you're going to do your x with the new piece. So 1 times negative 12 is negative 12, and the sum has to be negative 4. So multiples of 12 are 1 and 12, 2 and 6, 3 and 4. I need to add or subtract to negative 4, so this would add to 13, subtract to 11. This would add to 8, subtract to 4, so possible. This would add to 7 and subtract to 1. Now, if I add these, that gives me 8. So if I do 2 minus 6, I would get a negative 4. So 2 and negative 6. I divide by 1, which is 2. I divide by 1, which is negative 6. My answer would be x plus 2 and x minus 6, but you cannot forget the most, oh, you can't see, okay, you can. And you cannot forget the most important thing for this problem is that GCF, and you have to bring that GCF down and put it on the front. If you don't write the GCF, you will not get the entire problem right. Okay, so for 26, again, if you need to see GCFs, we're going to go math number 9. We're going to put 3 comma 30, and that gives me 3. Math number 9, we're going to put the answer comma 63, and that gives me 3 still. So the biggest I can divide out is 3. When I divide by 3, oh, hold on, before I divide by 3, they all have A's, so we take that smallest A also. So 3 divided by 3 is 1. 3 minus 1 is a squared. 30 divided by 3 is 10. 2 minus 1 is a. 63 divided by 3 would be 21, and 1 minus 1 cancels. Now we use the x on the new piece. So 1 times 21 is 21, and my sum needs to be 10. So multiples of 21 are 1 and 21, and 3 and 7. Those are the only multiples of 21. This adds to 22 and subtracts to 20, not the number I want. This adds to 10, subtracts to 4, so we want to add. So I'm going to put 3 and I'm going to put 7. I'm going to divide by that new coefficient of 1. So 3 divided by 1 is 3. 7 divided by 1 is 7. So I guess if I can use the right letters, I would do a plus 3 and a plus 7. And then I tack on my GCF of 3a at the beginning because that's the most important piece. You have to bring that back down. Okay, for 28 to find GCF, math over to number 9, we're going to do 5, 15. And then we're going to repeat and take the answer of 5, 140, which is still just 5. Now, they all do have an x. No, they all have a y, so we pull a y out. When I divide by 5y, 5 divided by 5 is 1. I have to keep the x squared, and 1 minus 1 cancels. Negative 15 divided by 5 is negative 3. I have to keep the x because I'm not dividing by x, and 1 minus 1 cancels the y. Negative 140 divided by 5 would give me negative 28, and 1 minus 1 cancels the y. So I'm doing my x with my new piece, so 1 times negative 28 is negative 28. My product has to be negative 3, so 1 and 28, 2 and 14, 4 and 7. And those are the only multiples. Okay, if I add them, 1 plus 28 is 29, 28 minus 1 is 27, not the number I want. 2 plus 14 is 16, and 14 minus 2 would be 12. Don't want either one of those numbers. 4 plus 7 is 11, but 7 minus 4 would be 3. So I do want this one, but I want it to be a negative 3, so I need my bigger number to be negative, so 4 minus 7. So 4 and negative 7, I divide by that coefficient of 1, which gives me 4 and gives me negative 7. So this becomes x plus 4, and this becomes x minus 7. I bring down that GCF of 5y, and there's my final answer. Okay, you're going to try these on your own now, so if you have any questions, stop and ask.